very happy that I managed to assemble a nice team of panelists. So to be honest, this is a bit embarrassing, but we kind of scheduled the panel, and then I woke up this morning and I realized, oh my God, there's this panel. What are we going to do? So I was fairly lucky that I managed to convince these esteemed gentlemen over there to participate in our panel. They're all going to introduce themselves in a second. There's Peter Coyle, who's going to be hosting it, and then we have 5 chairs for 5 participants. And the topic of the panel discussion is the state of data science and Python in Berlin/Germany/Europe. And I'll be in the audience with this microphone here, so feel free to ask questions for the panelists. We're trying to create sort of an interactive discussion as well. Anyway, please, let's get started.
So thanks everyone for joining us for this. I'm going to first start by letting everybody introduce themselves and sort of tell what area of the data science spectrum they're in. And then I'm going to ask a couple of questions and get a bit of a show of hands from the audience, because I'm very interested, not actually living in Berlin, I live in Luxembourg, despite being Irish, what industries you're in, because I imagine there's a different set of people here than you would get in PyData London or in PyCon Ireland or any of the other events. So could we start with Felix?
Yeah, so hi, I'm Felix. I'm actually coming from particle physics, so working there as, let's say, data analyst in the bigger experiment at CERN and Fermilab. And from that corner, I'm now working also more like on the scientific corner of the machine learning stuff. And I'm in Blue Yonder now. So this is a company which is delivering software as a service, predictive application solutions for customers from, I don't know, all kind of industrial sectors. And there I'm mostly working in the development of our core libraries. So that means we are actually building stuff for the customers which they need. But for that, we have to have our own methods and extend all the stuff which is there in Python, which we are using exhaustively. And for that, we are developing a lot of things, a lot of cool stuff. And this is where I'm in.
Okay, Trent.
Hi there. I guess you saw me talk this morning, but my background is I'm trained as an electrical engineer and a computer scientist. And I've been doing artificial intelligence related things for about 20 years. Doing radar classification and doing a lot of stuff for the semiconductor industry, and with my most recent company in the world of web scale, internet, machine learning, that sort of thing. And a whole variety of different tools I've used under this umbrella of artificial intelligence. Some that would be considered machine learning these days. You know, back in the days we called it, there's all these different things, right? Fuzzy logic and evolutionary computation and a whole bunch of different subfields that overlap, and I've pretty much done them all over the years. And at scale too, you know, up to 1 trillion points, you know, 10 dimensions, 1 million dimensions, all these sorts of things. So covered a lot of ground. And my role has always been CTO of the different companies I've been involved with. I also have a PhD in the relationship between computers and creativity as applied to computer chip design. So that's my background, and it's really a pleasure to be here. Thanks.
Hi, I'm Daniel Rios. I learned to program 3 years ago, but my background has been in a lot of problem solving. I have a bachelor's degree in literature, if you can imagine that. And I work for Paper and Tea, which is a tea company. I do a little bit of programming there, but I'll be speaking in my capacity as, in my free time, I'm one of the co-chairs of the Python co-learners group in Berlin, which is held under the Open Tech School Berlin umbrella. Every other Monday, sorry.
Hi, I'm Cheney Ujinaka. I'm founder CEO of Chokro. Chokro is an index that helps venture capitalists understand or make decisions around private companies in Europe. So really similar to Metamark in the US, in Silicon Valley, and in New York, CB Insights. My background actually is in healthcare. So I spent quite a lot of time in healthcare. I guess, worked worked within quite some large companies, one Humana in New York and Aetna in London. So both are large health insurance organizations. And in those roles, within the M&A shop, my role was actually to help detect trends, look for ways in which we can kind of build algorithms to make decisions on some of the deals that we were making. So today I'm going to be talking a little bit about venture capital, the index that we're building. We're building that on Python, and some of the insights that we've already gathered from that.
Hey, I'm Nico. I work at iQuant, which you can see just between us, where I'm responsible for product development and tech. If you're not familiar with what we're doing, we call it, well, I'm going to call it today, human perception prediction, which essentially where we do two things at the moment. One is we can take images of websites, display ads, and email designs and tell you where people are most likely to look based on a whole bunch of neuroscience research that's kind of ended up in eye tracking data, which we've used to train some models. And we also have in development and live a number of scores where you can sort of get a score on how likely it is that certain people judge your designs in a certain way. So the one we've got right now is one which can tell you how cluttered your website is, for example, which, as you can imagine, if you're trying to do some marketing and have a message to show, is what people are interested in. My background, I thought I was going to say I'm the odd one out here because I don't consider myself a data scientist, but it seems like I'm not the only odd one out. I do have a background in computational linguistics, so of course there was some machine learning and number crunching involved, but I think these days I probably couldn't matrix multiply my way out of a paper bag, but I hope I have some perspective because we, of course, use a lot of the NumPy, scikit-learn, etc. tools in all our modeling.
It's a bit like past partial, isn't it? So that's a very interesting mixture. So let's just have a show of hands from the audience. Who here self-identifies as a data scientist? So, and we're at a data scientist conference and not everyone's hand went up. That's very interesting. So what about like an industry split, right? So my Bayesian prior would be that everybody be in e-commerce, but I'm probably wrong about that. So what kind of like, let's start with industry and research, right? So who's in research? So about 50% of the audience. And who's in industry? So it's about a 50-50 split. Or maybe I miscounted that. So if we look at the research and what about biology, the sort of the life sciences, firstly, life sciences, and secondly, the hard sciences, so physics. Sorry, that's a bit controversial. See, it's a good way to excite the audience, just offend them. What about in the industry split? So who's in the e-commerce sector? So not everyone. What about marketing? I'll have to go with other actually for the rest of the. Sorry. Okay, so that's an interesting mixture we have here. So we're going to start with the first question, which is what does the panel think of the data science scene in Berlin? And then we can extend it to Europe. So I'll start with Felix.
So for the Berlin stuff, I think we should start with Nico, right?
Well, it's a great question. I think, when you've got your head down and building stuff, it can sometimes be really easy not to engage in the scene at all. So I am really amazed by the turnout we've had here. Like I've been to one or two PyDatas before, like the meetups. I've been to one of the machine learning meetup groups that are around here. I'm just blown away by how much turnout there's been here and the quality of the talk. So I think there's probably a lot more to it than meets the eye. and but sort of from my personal perception, I think Matt in his first keynote yesterday had this nice like segmentation of data. You know, you've got the gigabyte data, the terabyte data, the petabyte data, and for what we're doing, we're often dealing with relatively small data sets. You know, we've got maybe thousands of website PNGs or tens of thousands of those. They never exceed the gigabyte scale, and like a lot of the most interesting stuff is obviously in the terabyte scale because that's where everything breaks. But I would like to see more of the sort of like small data science stuff, and maybe there's a lot of it out there that I'm not aware of. But yeah, that's.
Sure. Yeah, I guess my take on the data science, I guess, field here in Berlin, it's still kind of developing, at least from what I'm seeing. If I compare it to some of the other places, for example, London, there's definitely room for improvement. I think that at least what I'm seeing here with data science is that a lot of it is limited to e-commerce, and that it's still, the definition as well is something that is still growing. So there's definitely a lot of debate around what is a data scientist. What are the skills that you need? Are we talking about you having, I don't know, like business intelligence skills and you using SAS? Or are we talking about you being using machine learning techniques? So that's definitely a lot of that there. But yeah, I guess I would say that it's developing, and at least from what I'm seeing in Berlin versus in London, yeah, there's definitely, it's growing.
So when I started going to the Python co-learning group, one of my focuses was, web technologies, and I was really glad to find a lot of other people doing Flask, doing Django. But as time went on, I started to notice people that I was like, oh, well, what do you do? And they go, well, I'm a biologist and I'm doing, and then they would say something that I had no idea about. But they were using Python this way that I never imagined that it could be used, because I never paid attention to the scientific aspect of it. There's also, we get a lot of people, a lot of beginners who are in physics and biology, and they sort of want to take control of their own data and analyze their own data. And we get, sometimes they come 2 times, 3 times, but there is a lot of interest, I feel, especially amongst people in the sciences, and not necessarily at big companies, but just people doing it for their own research or their own labs.
So I'm one of the 3 core organizers of Machine Learning Berlin meetup group, and there's about 900 members in it. And we have monthly meetings, and every single time it fills up. Our biggest challenge actually is getting venues that are big enough each time. So sometimes we have a venue with 40 people, sometimes 60, sometimes 150. In fact, we've had several meetups in this room with 150 people, and there's always a waiting list. So to me, that's very promising. And the people who give the talks, it's actually a really high caliber of talks that we have. We're always very impressed by the ones that come through. Besides that, the other groups that are sort of more prominent in the Berlin scene, there's the Algorithms and Data Challenges group run by Alex Weiss, and it's about every 2 months. It's got really excellent speakers, etc. There's the Big Data Beers group run by a couple also Python experts, and it's also like really great. And there's a machine learning group for learning run by Marcel Ackermann of Amazon, and they meet up every, I think, 2 weeks also to learn and improve. They review papers, all of this. Besides those groups, which are very active, there are several other meetups that are, a little less often, but also quite popular too. So from the perspective of, the meetups that are happening, there's quite a lot going on actually. And to me, it's been quite exciting to see. And all of these groups sort of emerged in the last sort of year and a half, 2.5 years. Some of them even in the last 6 months. So from my perspective, that's quite exciting. Within companies and so on, I have some visibility. I probably don't have the best, but at least from a meetup perspective, I see a lot, and I see a lot of not only quantity, but quality.
Yeah, so for me also, I think the conference talks are really great. So what I liked most is that we are not too much still in the scientific corner of the thing, but there are a lot of companies now also here. We doing technical talks. So, and to what Nico said, so I think this is, so we are mostly in for the machine learning stuff, we are in small data sets still, that's true. But actually in industry and Internet of Things and all this stuff, so we are really facing there the bigger data sets now. So I think the ideas which were talked about on this conference are this what we are actually facing at the moment as well. So that we see that we need some out-of-core solutions, that we need some algorithms which can be streamed and so on. So I think this is very interesting that to see that this is also coming a bit to this community here. And yeah.
So that's very interesting because I come from a physics background as well. So like, and I haven't had the proper computational training. And it's amazing how I constantly run into challenges that I have to pick up what out of core is. I probably didn't know what a RESTful API was 3 years ago. So, and so I guess this here kind of is, are there any questions from the audience, or do you want me to go on with the next question? So there's something I just, oh, sorry. So, go on.
Hi, I'm also a physicist, and actually I have a remark to your question and also what I've heard here. You asked for, are there sitting here people who are doing e-commerce and marketing? And then it is said, well, it's not not a lot about other things in Berlin. But you actually have not asked it. So my background is physicist, and many physicists learned MATLAB and then went over to Python, yeah? So engineering is, of course, also an important thing to ask.
So I guess the follow-up there is to sort of have people comment on what other industries there are. I know I'm sorry for leaving out physics and the kind of industrial engineering. But no, like if I have a finite set, I'm going to leave someone out, right? Yeah. So there's kind of a branding problem there, right? You know, so like you talk about Python, a lot of people think web apps. You know, so I've been at like a PyCon, and everything was quite web app dominated, whereas there's a different skill, sort of set of skills. So I'd like to ask people to comment a bit on what they think the industries are in Berlin and in Europe who are using data science.
Yeah. So, compared to the US and the UK, maybe, so we have not too much coming from finance or insurance and that thing. So mostly I would say in Germany and then also in Europe, mostly it's what we had, for example, is mostly retail in the past. So just because the pressure was the highest, that they need some sophisticated methods to earn some money. And in industry, for example, this wasn't the case in the past. So there still was so much money in that it was not necessary to have the last percents out of your data. So, but this changed now with all this Internet of Things stuff. And I think this is now catching up. So there will be a lot of things to come in industry and all these things. And I think this will be pretty interesting in the future.
So the question is, what industries are using data science? And to me, it actually comes down to what is the definition of data science? I have to admit, I'm really not a big fan of the label data science. I never have been. I think that there's, it has the word science, yet a lot of the time what you're doing is engineering. Whereas in science, what you need to do is, you have questions that you want to answer, you pose these testable hypotheses, you come up with an approach to do it, you gather data, then you do an analysis. But a lot of the time, people who claim to be data scientists or doing data science are just wrangling data, right? So in my view, rather than the label data, and then I've also seen kind of related to this, the problem of the label, a company hires a data scientist or a team of data scientists and they're like, go play with data, but there's no actionable outcome. And I've even seen this in the companies I've been involved with, where we would hire algorithm teams before the word data science was sexy. And these teams failed, actually. And we actually, I have 2 different cases where we hired these teams, we disbanded those teams, and we put them part of engineering and product development. And then we had technical spikes. And from those technical spikes, you know, where you go away for 2 weeks or 2 months, you have an actionable outcome at the end. So in terms of that, that's kind of my view is, what are the different skill sets that kind of relate to data science? There's database engineering, which is simply, you know, data keeps growing and now people call it big. Cool. But databases have been around a long time. Machine learning, right? There's been simple analytics for decades, statistics, all of this, right? Now the modern statistics happens to be called machine learning. Cool, and there's a lot of great new tools. So, I mean, and these happen to have broader applications. So my kind of view is the bulk of what is called data science is really machine learning and databases, but these are engineering roles and product development roles, and that's where I like to see them. What industries? To me, like, I mean, databases are everywhere, right? Statistics is everywhere, and so data science, in a sense, is everywhere.
Oh, Trent, you stole my answer. One of the things that I've noticed in some of the companies that I've worked for and the people that I've talked to is that there's a lot of data being pulled, there's a lot of data being collected, but not very many decisions being made with the data. It's just sort of like, oh, we have, you know, big data, we have all these servers running and numbers crunching, but in the end there needs to be an outcome. There needs to be someone who makes the decision, says, okay, we're going to put 85% more money in the marketing budget, or we're going to, you know, increase the physics department spending. And I sort of feel that in a way, we have all these tools, we're doing all these things, but we need to almost push a little bit further and say, okay, what was the outcome of my return statement? You know, what happened to it? And I think sometimes with a lot of my data that I generate, you know, I don't do the follow-up, partly because, you know, I'm not the decision maker, I'm just sort of delivering the data. And it almost feels like when you deliver data that's unused, you sort of feel like, you know, what was the point? Except that you learned something awesome, you know.
So I'm going to comment on 2 industries. So the first one being healthcare and the second one being venture capital. In terms of healthcare, I'll use my US experience as an example. So in healthcare, some of the things that we were looking at with data was for insurance, is how do we manage costs using large sets of data that we already have on consumers. So in this case, when I worked for Humana, for example, we were managing a little over 5 million members. So we had a lot of claims data on these customers. So everything around, you know, how do we decide, or how do we prevent pain, essentially, and how do we estimate what we pay for, you know, for condition areas. So just to give you a sample of some of the data that we did, some of the things that we did. Second example of healthcare application around big data, epidemiology. So a lot of people talk here about data science, and if you ask a lot of healthcare folks that have studied statistics for epidemiology, they'll tell you that, well, I'm never changing my title. It's epidemiologist. You know, I manage disease conditions and populations, and I try to predict who's going to get cancer, or who's going to get, or who, you know, who's going to be morbidly obese. Going back to your comment earlier about the definition of data science, Nate Silver said that data science is essentially a sexed up term for statistics. So that's just another good example there. So now in terms of second example, I'm going to go back to Berlin now. So Berlin and venture capital. So what are we doing at Chakra right now? Essentially what we're doing is collecting, you know, it's kind of small data sets, right? Collecting data sets from startups or private companies is what we call them, around growth. So things like, well, your key KPIs, so cost per user acquisition, burn rates, churn rates, revenue growth, customer growth, and then using that to not only connect them to venture capitalists based on an index that we calculated on the back end using Python, but also trying to predict success as well, and actually look at aggregate. So looking at, you know, companies on the Berlin level, looking at companies on the European level, and then obviously trying to draw various insights from that. So obviously in Berlin doing that, it's a little bit of a challenge because I don't think anyone has mentioned this here, but when you stop sort of experimenting with data science or with data, and you want to actually apply it in a financial sense, there's definitely a lot of regulation, a lot of resilience to that, because it's still developing. So that's the biggest thing that we're finding here, is that when you start applying data to certain industries that are super regulated in an environment that is not comfortable with transparency, you have a little bit of pushback. And so we're seeing that here in finance, but also here as well in healthcare. So there was a study done recently that said that in Europe, there is a shortage of 50,000 jobs in data science. So it just kind of gives you a sense of some of the applications there.
Yeah, I think there's not much that hasn't been said on this topic now. I think going back to the original question about industries, right? I think I kind of see a bit of a like three-tiered pyramid. There are the companies where you can make data science and, if you want, predictive modeling a core product that you sell. Like this is what we're doing, for example. And I think it's a very nice place to be in because you get to do a lot of interesting stuff. But there's a limit to how many like categories there are, right? So it's no surprise that not a lot of you didn't name a lot of them. I think below that there's a level which is much broader, where much more data is just being produced over the last decade or two that can now be harnessed to create product features to kind of improve an offering or give like a new angle that wasn't previously available. And I think, much like Trent was saying, that's everywhere, more or less. And then on another layer below that, you kind of have what was probably traditionally business intelligence, where you kind of can use data science to achieve certain business goals that not necessarily sort of like surface at the level where an end user might see it, but it helps improve, the kinds of offerings you provide, or the way you message something, or your revenue figures and all that. And I think that really goes into all industries. I don't think I can think of one that couldn't benefit from that or won't be changed by that in the future.
I think we have another question from the audience.
I have a question about the synergy between the research and the industry. So, in the research field, people do sometimes very basic research and find some optimized algorithm and like that. Whereas in the industry, people have just set up tools, stabilized tools to use to analyze their data or something. So how the industries are active to look the recent research output from the academia or research labs?
So I guess, who wants to take that one? Go.
So I've actually been on both sides of the fence here, where I was a student that was funded by industry, and also where I was the industrial partner funding students. And it works. In my view, the company should never, ever rely on the output of the student. That's the core sort of principle. It's basically a bonus. So basically, if the student manages to pull something off, then great. So that's kind of one thing. And the other thing is well-defined, well-scoped projects. And that's much more useful to industry. I think if you're a larger company, you can probably, and this is from the perspective of smaller companies. If you're a larger company with thousands of employees, sure, maybe you can, pay for a PhD student for, 5 years. It'll probably cost you €500,000 and go for it, right? And maybe you'll have nothing coming out. That's fine. If you want to have that label of that university on your company website or something, great. For smaller companies, though, it's more well-defined projects and so on. So, and we've actually had benefit from that in the companies that I've been involved with, where we have these well-defined research projects where a master's or a PhD student works on it for 3 months, 6 months, 9 months. They present the results, and we sometimes integrate that. There's other ways too, where we provide the industry can provide tools or free access to software. That's very helpful, as well as universities are often looking for industrial partners. So just attaching your name to that that research proposal, that grant proposal, can be very, very helpful. And I've been, in general, the companies I've been involved with, we're very open about that. Even if we don't see any benefit, if the professor wants to use our company's label and to go for it, great. I just say we're not going to commit much time or resources from our part. We'll commit some, and then it'll benefit you, and maybe we'll get some benefit. But in general, never ever to like expect a whole lot at the end. You know, anything that we get is gravy. But this is also beneficial from a student angle, right? Because then you say, I'm working with this company, I'm working with this supervisor, this is how it might get used, et cetera, et cetera. So just understanding the needs of both sides.
Yeah, the good question. I definitely think that it depends on the industry and the company. Some companies are very open to research and using research to draw insights. I'll say that, I'll give you an example in our case. So right now we're having conversations with some universities around what we're doing. And I think the biggest thing that, at least for industry, is typically when you're, in this case, in venture capital, you're trying to get information so that you can make decisions, not just to collect the data. And so some of the things that we talk about with that university is, well, we don't want to just do research for doing the purpose of research. We need to actually marry research with outcomes. So I think that's where I guess depending on the organization, you have those conversations and you figure out what you want to do. In terms of, at least in terms of what I'm seeing for certain industries like healthcare and finance, I mean, I've seen situations where pharmaceutical companies, this is a great example, they have their R&D teams and then they have the innovation teams, and a lot of times they're a lot of times they're a little separate, and they try to draw insights from that. So I guess it really depends on the organization, what the funding is, because some people don't like to waste the money, or they consider it wasting their money. Yeah, I guess, yeah, that's my comment.
Just okay, thank you. You had a discussion about what is data science. I would have a question, what is industry? You asked in boxes, and you told me out of the boxes. I take the machinery, yeah? Maschinenbau, Anlagenbau, and construction, maybe Germany, worldwide. And they have now the problem to find new products, new business models, new revenue streams, maybe. If they think about electronics or IT, it's standard. What we have, we can deliver this missing link. One example could be Germany, they talk about small politics, Industrie 4.0. But I mean this mighty industry of things. You measure something. You have MEMS, micro electromechanical systems are very low, very much degree of freedom, you can measure and control and so on. But you can put them now into the business level and have new business roles. Could this be a new kind of thing we can deliver from this interdisciplinary approach we have, from this big data and also this data scientist knowledge, to help those people, not just revenue, but to understand better their business, to make them competitive in 2 or 3 years, because the machines are perfect. There's no tribology problem to solve. Okay, there are nano of them, yeah, but this is a percentage or sub-percent, yeah, promille. We are looking, okay, healthcare and some mass data and fintech, but could you comment on this? Because I think this is a very great shortage, and not only 50,000, we could give some millions of people a better job if you support them with intelligent algorithms incorporated in machines, maybe a service not running on-site, yeah, or like detectors in high-energy physics. We have the basic data and only metadata, but this needs knowledge. You have to think. And I think this is what is shared here. We are thinkers and problem solvers. So out of the box means to have new ideas for new industries, maybe. You can comment on this? Thanks.
Sure. I mean, I'll say that like the quickest way to comment on that is when you talk about, I guess, data science or research or insights, and you want to go and sell that to organizations, a lot of times you're dealing with management. And you have to convince management, and some managers haven't been sold yet, right? If we think about what data science is and when it even started, I mean, I moved to Berlin 2 years ago, and back in the US where I was doing what I was doing there, we didn't even have that term. So it's still, there's definitely an educational process to go with a lot of these managers to figure out like, okay, so let's talk about the issues in your organization and how can we use our, our talent to draw insights with the tool. How much data do you have? How are you massaging that data right now? How are you drawing insights from that data? And how can it help you like benefit your businesses? So that's it, number one. Number two is, within the organizational structure, at least for large organizations, you have quite a lot of like silos. So you have the IT director or the IT VP who might be already up to date with data or trends or still in the old world. Or you have innovation department, so there's various silos, and you kind of have to either figure out how to work with a champion with the organization to make that happen, or figure out how you can get all of them to collide. As you can imagine, a lot of these organizations have meetings with 50 people in it, for example, or 10 people in it to make decisions. And so each one has to be convinced about the value of that.
Very short comment. We are familiar with this, we know this. These are large organizations, these are silos, these are monoliths, these are dinosaurs. But if you go to German Mittelstand, you know this? They are very eager to be competitive. We call them hidden champions. Yeah? So they are the best, they're not known and not visible. But Trumpf, you know Trumpf? It's in Schwabenländler. They make soldering or laser cutting and things like this. They want to deploy something like an app store for their machines. They don't know Google or the Apple Play, or of course they know this. But they say we need a store for apps for our machines for refurbishments, yeah, for reconfiguration, edges, etc., etc. Yeah, but they're not in this world. So they come from the business side. They come inside, so they know their business. And management, this is family owned. This is slightly different from the big companies. And I think they think very forward and eager to have this, or Bosch, maybe same. I think we can deliver this missing link and address the people who have budget, or better, go to the people with profit and loss. And they have this understanding. Don't come with data, don't come with Python or IT, no. Domain-specific language and knowledge and annotation. I think we can help them.
I mean,
sorry, it was
maybe a comment
longer.
on that. So I think in the end, it's all about the business cases. So you have to find with expertise, domain knowledge in that specific area, you have to find the things which are really bad for the customers and come with a business case, and then you can convince. And of course, you need some champions inside of the companies to convince the others. But usually, you cannot come without a business case. Then you are just out. So this means you have to understand the business of the customers.
So that seems like a very good opportunity for any consultancies there in the German area. I'm going to have to wrap this up because it's lunchtime and I'm hungry. But it was a very interesting set of experiences there about the branding and the challenges. And I completely agree about the champions in organization. There's a lot of educational selling that needs to be done. And a lot of workshops I've run in Luxembourg have been to business leaders about what is data science, why should you care, these sort of things in the community there. And I notice a lot of people throughout Europe are still running these sort of things. So that means there's tremendous opportunity for growth. So it's a very good time to join these sort of worlds. So I'd like everyone to thank the panel. They were great. And does anyone have any final words? Because you all have lots to say. Yeah.
I think one of the main things that we should be pushing for, especially all of us that know Python already, is try to encourage more people to learn the language, because I'm coming from a literature background. Python made sense for me. When I looked at it, it was clean, it was pretty, but at the same time, it was close to English that I could understand it. And I feel that in Germany, it's almost expected that if you're a programmer, you have a CS degree, you have all these papers in your CV saying, you've done all these awesome things. And we need to not only educate people in programming, but also educate people that programming is a tool. It's like a hammer or a wrench or a nail, something that you can use to get a final result. And I think that's missing in some people's perceptions of what we do. I mean, a lot of us aren't CS graduates. We come from varied backgrounds. So it really means that anyone who can solve a puzzle can learn to program.
Okay, thank you very much.